Happy Friday, y'all. Today, we are going to continue to help the superintendent in answering this big question as we continue to think about our little bottlenose dolphin family here. How does sound energy travel? This week, we've been learning that sounds can travel through different kinds of materials. And when we think about the different kinds of materials, we're thinking about air, we're thinking about water, and we're thinking about the ground. So, different animals communicate through different materials, which we know. And we know, of course, that the dolphins are communicating through water as their material. Materials are made of particles that are too small to see, which we've also been learning. Today, we're going to focus in on particles and we're going to focus on how particles function. Like we're learning more about particles. We're seeing these particles and these orange dots in our simulations. And so we want to just get a deeper and clearer understanding of, okay, how do particles work? Um, we can't see these particles, but they're all around us. And so we really want to continue to use our STEM today and our text to help us understand particles even more. This week, we've learned some vocabulary words. We've learned what material is, vibrate, and particle. We learned those three definitions. Remembering that having a clear understanding of these three vocabulary words and the one we're going to learn today is going to definitely help you get all of your points on your CER. The more scientific language you can use in your CER, the better your grade will be. So remember, these are some of the words that I should hear or read, in your CER when we come up on our next assessment. Today's vocabulary word is collision. What is collision? Collision means things bumping into each other. So we've talked about things colliding before when we talked about energy and we talked about movement and we talked about cars sort of colliding into each other. Now we're actually going to focus on particles colliding into one another. So when we hear language that says the particles are bumping into each other, we know that our scientific term is actually going to be the word collision. So when particles are bumping into each other, we want to think about particles colliding into each other. To help us see how particles collide into each other, we're actually going to look at the sound wave simulation again. But this time it's going to be a little more challenging because we're not looking at all of the particles that's on the screen. We're actually going to focus on one particle. And I guarantee you it is going to be a lot more challenging than us making observations in the simulation yesterday and the day before. Let's go ahead and get into our classwork because I think you guys are saying to yourselves right now, oh, Miss Adams is going to be easy. Stop playing with us. But I guarantee you, it's not going to be easy. Watch and see. Here's our classwork as usual. When you get to your book, you can get your book here. You can get your sim here. You'll click on those links to get there. Our objective today, I will be able to create models of sound wave patterns by analyzing air particles. Now, it's going to be a little more difficult because we're not in the classroom. It's going to be more difficult to create these models together. But you will have an opportunity at the end of your assignment to, if you have the resources, to create your models at home and send me a picture. But we are going to more so focus on these sound wave patterns by analyzing the air particles, more so than creating models today. Again, in blue, and always at the top in blue, you're going to have your definitions. So remembering, I prefer that you use the definition in blue so that we are all on the same page when it comes to you having to answer your definitions, writing your definitions in your PDN. Please use what's in blue so that we are all on the same page. All right, observing our sound energy traveling today. I can't say it anymore. It's going to be challenging, you guys, but I know you're up for it. We're going to open our sim, and again, to open your sim, you're going to click the link at the top of this page. We're going to choose an instrument and press play. And this time, we are going to only focus on one particle to watch, and this is what's going to be difficult. We're only focusing on one particle to watch. We're going to observe the motion of that one particle as the sound energy travels across the screen. Together, we're going to complete this first row, and by yourself, independently, you will complete the second row. The first instrument that we're going to complete together and observe together is going to be the violin. So I'm going to go ahead and type that in now. This is what we're going to focus on and observe together first. So when you get to this page, and if you have a difficult time with that link and clicking and getting to this page, please look for the Amplify login info sheet. It will have all of the information you need to log in to get to this page. When you get there, click the orange number 1, that's sound waves. It'll lead us to today's SAM. Don't forget, our focus is the violin. That's what we're going to observe together. So I'm going to hit view all sounds, go to violin, which is a lot quicker than hitting those arrow buttons. And then I'm going to press play. Now here's the challenging thing, which is going to cause me to have to do it over and over again. And don't forget, that's what scientists do. Sometimes we have to repeat the process to really make clear observations so that we can really get to a good answer. So when I press play, I'm going to quickly have to find one of these particles and keep my eye focused on that one particle. So for example, if my focus is here on this one particle, when I click the play button, I'm going to need to follow this little guy around, and it's going to be more difficult when the vibration begins. So let's go ahead and give it a try. So now I'm focusing on this one particle, and as soon as it hit that vertical line, I lost it. So I'm going to try it again. But even though when you lose that one particle, you still need to be making observations and thinking about where did you see it go, or where did you last see it. So here I'm going to focus on this little guy. So I noticed that the one particle, before it hit that vertical line, I noticed that it was one moving, right? We can say that for sure. But I noticed it was moving in a short distance. The one particle that I was focused on, it never reached to the far left or to the far right of my screen. It always stayed in this area. And so these are the notes that I'm writing down. So when I get to my classwork, I can write that down in that box. So I'm going to do it again. Focusing here. So that one dot that I focused on that time, it moved back and forth. So before I noticed the one dot was moving in a short distance, I noticed this dot was actually moving back and forth once the vibration started. It didn't go up and down as much as it went back and forth. And I also noticed that it was bumping into other little particles, right? This guy was definitely, once it started vibrating, bumping into other little guys. So let me go back to my classwork, and I'm going to start typing my observations and what I noted on my paper. So if you want to do your bullet points, you can go ahead and press the subtraction button, which is at the top by the 0. Press your space bar and it will automatically do that spacing for you. And so I noticed my particle was moving at a short distance. It didn't go from here all the way to the left or from here all the way to the right, but it stayed in this little area, which means it didn't travel far. I also noticed that that one particle was moving back and forth once the vibration started. And as it was moving back and forth, we noticed that that particle bumped into other particles. So these are 3 things that I noticed and observed during the violin observation. And so what you're going to do on your own is choose another instrument and talk about what you notice. What did you see? And again, you're going to have to do it over and over again, because I just don't believe one of you guys are going to be able to focus on that one the entire time. I challenge you. I really, really do. So choose another instrument. Choose a very interesting one. The drum or the flute would be very interesting for this observation. And then go ahead and write what you observe here. We're going to continue to the next page, and we're actually going to do some reading reflection. But before we do that, I want to come to this slide because we have a diagram. We have a diagram of one particle sort of moving, and it's a still shot, so you can actually have a better understanding and visual on a particle being moved around. So we have the violin instrument, and this line right here represents the vibration that we saw in the simulation. So if we could visualize this line vibrating, moving back and forth, we know that that starts to move these particles even further and back quicker. So it starts moving them back and forth a lot quicker, and we know that it shifts into this vertical line. And if we were to focus on this one particle right here, this little guy eventually moved its way towards the left, went here, bumped into some other particles, and eventually made its way back in this direction somewhere. And that's what we saw, but we just saw it in motion. And this is sort of what we already saw and wrote about, but just at a standstill. And so that's what would happen with that one particle. Now, when I think about it bumping into other particles, I'm definitely connecting back to this vocabulary word we learned today, collision, right? So this particle here ended up colliding into another particle, which made it bounce over to another particle and probably collided as well. Thinking about particles moving in real time, let's go ahead and get to our second part of our classwork. You guys have read about the mountain bluebird already, but today's focus is going to be who's the listener and what does the sound travel through. So together we're going to read the mountain bluebird. Independently, you will read these other two sources, and here are the pages for you to read. And then you're going to also tell me the listener and what that sound travels through. Let's go ahead and get into the mountain bluebird. All right, so here we're thinking about, don't forget, the listener, and we're thinking about what, how they communicate, what material they use to communicate with. Let me go ahead and try to get this a little bigger. All right. How do mountain bluebirds communicate? Mountain bluebirds are common in the mountains of the western United States. These birds spend most of their time flying through the air. At dawn, mountain bluebirds sing a loud chirping song. They sing a softer warbling song during the rest of the day. Like all birds, mountain bluebirds use the air to communicate. So I'm hearing an answer there. Air is the material that mountain bluebird songs travel through. This is our exact answer right here, right? Air is the material that mountain bluebird songs travel through. So when we get back to our classwork, I'm going to make a note on my paper that air is that material that they communicate through. Remember that air is made up of tiny particles. We can't see these particles, but a diagram like this one can help us visualize them. So here we have air particles, right? What do you notice about these air particles? Well, we notice that they're not closely together just yet. We know that the arrows represent movement of those air particles. You might see that the particles have lots of room to move freely. They do. Let me go ahead and go to the next page. And let's zoom in a little bit so we can read. Mountain bluebirds are a type of songbird. All songbirds have a special body part called a syrinx. The syrinx is different from the human voice box. With its syrinx, a mountain bluebird can make two sounds at the same time. To make sounds, a bluebird sends air through its syrinx. The moving air vibrates the walls of its syrinx. When the syrinx walls vibrate back and forth, they disturb the nearest particles of air. These particles then collide with the air particles next to them. Those particles collide with the next particles over, and so on. We call this pattern of motion a sound wave. The vibrating syrinx is the source of the sound wave. The sound wave travels by way of particle collisions all the way to the bird hearing the call. That bird is the listener. This is our second answer here. That bird is the listener, and they also talked about those particles colliding. So, who was the listener? Other birds. What does the sound travel through? We'll just say air. That is what you're going to do for these other two sources, for the sperm whale as well as the kangaroo rat. Tell me who the listener is and what material they use to communicate through.